So we will be talking about mechanisms, and what we mean by reaction mechanism is just a step-by-step description of which bonds are breaking and which bonds are being made that occurs in a particular chemical reaction. So halogenation occurs via what's called a free radical chain of reactions. It's not a single step, but there's actually multiple steps, 3 steps. So this mechanism has 3 steps. The first step is called the chain initiating step. And this is where the halogen molecule breaks into 2 halogen atoms. So here we have, we're looking at the Lewis structure of the chlorine molecule. And what happens, we've got these curved arrows that it has half a head. Just one of those little, I'm blanking on the name of those. We'll call it a half arrow. So this 1 electron is going over here, and 1 electron is going over there. So you could think of this is a married couple. They have 2 children between them. They're splitting up, and then, okay, you take that child, I'll take this child. Kind of like in The Parent Trap. They were the twins, and they each took one. Right? So that obviously is not going to just happen by itself, because Cl2 is a nice stable molecule. Each chlorine atom is happy with its little octet, and everything's nice. To break them up requires some energy, and that's where the light or the heat comes in. Light is a form of energy, and so sunlight on chlorine causes the chlorine molecules to break apart. And so we end up with these 2 chlorine atoms. Those chlorine atoms, do they look very happy? No, they don't. They're not very happy. They are very reactive. So the next step is the chain propagating step. So these reactive chlorine atoms, one of the things they can do is they could recombine. They could react with each other and recombine to form Cl2. That can happen. The other thing is this reactive chlorine atom can transfer or say, hey, hydrogen, I'll share this electron with you if you share one of your electrons with me. And basically steals the hydrogen away from the alkane. So now R and H are splitting up, and they're each taking 1 electron from their shared covalent bond. So hydrogen takes his electron, and chlorine shares with him, and they go off and they make a bond. What we have left here is called an alkyl radical. It's an alkyl group that has this lone electron here, an unpaired electron. It's missing a hydrogen atom. It got pulled off. Does that guy look happy? No, not happy. Because that's going to look something like, this could happen with methane. So the methyl radical is going to look like that. Carbon does not have its 4 bonds. It does not have an octet. It is not happy. So this alkyl radical got its hydrogen stolen, and then it can go to a chlorine molecule and steal away one of the chlorines. So these 2 chlorines are splitting up. Each takes 1 electron. These guys are going to share between them and form an alkyl chloride, a bond between this alkyl group and the chlorine, which leaves this chlorine atom that's not happy. And the chlorine atom is going to go steal something. And so this is the chain reaction, the chain propagating step. This guy's unhappy, he takes something from somebody else. That makes that one unhappy, and he takes something, and it just goes on and on and on and on. So these 2 reactions are just going to cycle around and around until we run out of something. Eventually this has to come to an end. But in this propagation, what we have is, in each of these steps, a radical is consumed. Here it's the chlorine, and here it's the alkyl radical. A chlorine is consumed, but another is made. And that is the one that gets consumed in another step and continues the chain. So almost all of the reactants are going to be consumed. Almost all of the products are going to be formed in these middle steps. And then we have the chain terminating steps. And this is what happens when 2 radicals collide. So if you have 2 chlorine atoms, they can get back together and form a chlorine molecule. You can have two alkyl radicals combine to form an alkane, or you can have an alkyl radical and a chlorine atom combine to form the alkyl chloride. And when these things happen, the chain stops. So we'd say the chain is broken. Usually in the chain initiating step, many of these chain reactions are started. And so the fact that some of them get terminated sooner than others doesn't really matter. There's plenty of others to keep going. Any questions? So write equations for all of the steps in the free radical chlorination of methane to form methyl chloride. So what happened in the chain initiating step? Had to do with the chlorine. We have to have a radical be formed at the beginning. Carbon-hydrogen bonds are stronger than the chlorine-chlorine bond, and so it's the chlorine-chlorine bond that ends up breaking. So one of these electrons goes there and one goes there. And that doesn't happen spontaneously. We need light or heat, something, an energy source. And then the product of that is these two chlorine atoms. So that's the first step, the chain initiating step. And then the chain propagating steps, and here it's for methane. So we've got methane, and one of these chlorine atoms. So this chlorine is very unhappy. I tend to personify chemicals, if you hadn't noticed. This chlorine atom's really unhappy, and he's looking for another electron. He's like, I need to share with somebody. I'm not okay like this. So he's going to go over here and sweet talk the hydrogen and say, hey, I'll share this electron with you. And the hydrogen says, okay, I'll share this one. Each of these arrows being only having half of the arrowhead means one electron is moving. And then the other electron in this bond stays with, oops, that wasn't supposed to be a double head, stays with the carbon. So what we end up with then is this poor methyl radical. Carbon lost his hydrogen there, and the hydrogen and the chlorine are happy together. So what's this methyl radical going to do? It's going to go steal somebody away, right? So here's the methyl radical. Another chain propagating step is that attacking a chlorine molecule. So here, this chlorine atom is going to share its electron from the chlorine with this electron from the radical. And those two electrons are going to form a bond. So now we've got chlorine attached to the carbon. And then what's left for the other chlorine atom? What does it become? It becomes a radical. And then this guy can go do this step. And so it basically just goes around and around in circles here in these chain propagating steps. Does that make sense?
So all those, the steps just put chlorine, methyl chloride?
It's going to form methyl chloride, yes. Now, could it form dimethyl chloride? I mean, or dichloromethane? It could, but we're not going to worry about that. And then how's this eventually going to come to an end?
Or you get back together?
Two radicals combining with each other. So we can have, sorry, I'm getting lazy with my dots. I should do it this way. That's so much easier. So those two chlorine atoms can recombine to form chlorine. We can have a chlorine radical and a methyl radical combining. And often we'll show, these are going together. And then I'm running out of space. So that would end up with another one of your monochlorinated methanes. I'll draw this guy way up on the top. You can also have two methyl radicals combine with each other. So they're like, hey, we're going to share now. And what's that going to end up being? We'll get a carbon-carbon bond there. And what's the name of that guy? Ethane. Now, do you think we're going to make a lot of ethane? No. There will be a little bit. Because mostly what we have is chlorine molecules being broken because of this light or heat energy into chlorine atoms. And then most of what is the rest of this is methane. And the chlorines are going to run into methane, and then we're going to have this. This is very reactive. We've got lots of chlorine atoms around, and so this reaction, or this reaction are going to happen more than this one. But this one will happen a little bit. When that happens, the reaction stops, and there you've got an ethane molecule in your mixture. So the chemical reactions that we do with organic chemistry, we don't usually get super pure products. And we just have to accept that. There's going to be some other products that get formed. Any questions? Yes?
What's the difference between chloromethane and methyl chloride?
It's just a style or a system of naming. Methyl chloride and chloromethane are exactly the same thing. Chloromethane is the IUPAC name because we go the number of carbons, one carbon is methane, and then we put substituents on in the front. That's the IUPAC, the official name. Methyl chloride is a common name or a trivial name. It's one that's been used for a long time, and it's like a nickname. Good question. Any other questions? Yes.
Do the molecules on the top, are they involved with the stuff on the bottom?
This is one of the chain terminating steps. So this is the chain initiating. There's three basic steps. Let's see if I can make that a little clearer because it's not very clear. So chain initiation, and this is off the board, so I'll try to do it over here. Chain propagating, these two guys in the middle, where one radical is consumed and a different radical is made. One radical is consumed, a different radical is made. And these guys keep the chain going. And then there's three different termination steps. That's this one down here, and this one around the corner, and this one up at the top. And in your book, it's laid out much more neatly.
You don't have to do all three pages, it's one of the three steps, right?
That's a good question. Would you have to write all three chain terminating possible? Each of the three does terminate it, but there's three different ways in which it can terminate. So I think it's best to do all of them. The chain terminating is two radicals coming together. Basically, they knock each other out. Propagation, you get rid of one, you make another. So here we had, in the initiation, you have no radicals, you're making a radical. Chain propagating, you consume one radical, but you make another, and so it keeps propagating. Chain terminating, you've got two radicals coming together and taking each other out. Because there are two different radicals, you've got different possibilities. You've got the methyl radical with another methyl radical. You have a chlorine radical with a chlorine radical, so two alike, and then you have the possibility of two different ones combining. You really have to be able to step back and see the big picture in order to be able to remember this stuff. But you should be able to, like if I said, well, how about the free radical bromination of ethane? You should be able to write these steps out. Yes?
So the last three steps, one of them, two of them are combining the same thing, and then the other one's combining two different ones.
Right. And let's go back. This is sort of the generic version, where here R could be anything. Could be methyl, so CH3. And one of them is two chlorine radicals, one of them is two alkyl radicals, and the third one is one of each. Those are the three different possibilities. These generic reactions with the R are really handy because it's not like we have to memorize the mechanisms for the bromination of methane and the chlorination of methane and the chlorination of ethane. The process is the same. The only thing that changes is what is R. Is it CH3CH2 or is it CH3? Just different combination of carbon and hydrogen. There, we've at least finished chapter 2.